myself Dr. Bharti Patil, working as an assistant professor physics in Maharaja Jivajirao Shinde College, Srigonda, Ahmednagar. We have started our syllabus related to solid state physics. In that we have started our second chapter, that is X-ray diffraction and other characterization techniques. In our previous lecture, we have seen few of the methods of X-ray diffraction, that is Love method and rotating crystal method. In today's lecture, we are going to see one more method of X-ray diffraction, and that is called as Debye Scherrer method or powder method. Debye Scherrer method or powder method is the method which is used to study polycrystalline materials, that is the materials which are in powder form. Because in case of Love method and rotating crystal method, the disadvantage is that the material which has to study should be in single crystalline form, and in world most of the materials are not in single crystalline form, and it is difficult to synthesize such type of single crystal materials also, and hence it is necessary to devise one more device or the equipment which can study the powders or the material which is in powder form, and such type of method was invented by Debye and Scherrer, and hence it is named as Debye Scherrer method, and it is basically used to study the crystalline materials which is having powder nature or polycrystalline nature. And in this method the material under study should be in powder form, and hence if the material is having more size, then we have to crush it or ground it with the help of agate mortar, and that sample is utilized for the further study. Here we are in need of Debye Scherrer camera. Here I have not shown the camera, but the same as we have used in rotating crystal method, such type of camera is there, and inside that camera there is the photographic film which is covering the entire internal surface of the camera, and a sample under study, that is powder crystalline material, is attached to the hair, because hair is non-diffracting material, and the material under study or under observation is attached to that hair with the help of glue or gum, and it is suspended at the center of the camera, and after that a monochromatic beam of X-ray is allowed to incident on that sample. And initially this X-ray beam is not having monochromatic nature, as the source of X-ray is producing polychromatic X-ray beams, and in order to make them monochromatic they are allowed to pass through filter. What is the role of filter? Filter will block the unwanted wavelengths and allow to pass only a single wavelength under study, and hence the beam which is passing through the filter or coming out of filter is having monochromatic nature. After that, in order to make that beam fine, because we know that the energy of X-ray is tremendous and our requirement of X-ray is very less. If we use the thickened beam or broad beam, then due to that higher or excess energy, there might be heating problem. And in order to avoid that, this X-ray beam, monochromatic X-ray beam, is allowed to pass through the lead slits. These are two slits S1 and S2. They are made up of lead. And what is the property of lead? So when X-ray beam passes through lead, then it will pass through the holes which are in slit S1 and S2, and other excess amount of X-rays will be absorbed in L1 and L2, and hence we can get a fine beam of X-ray which will then incident on a crystal under or the powder under study. So I have told you the requirement that the material which is taken should be crushed to a fine powder, and it is mounted at the center of Debye Scherrer camera, and it is attached to here with the help of glue. Now we know that when the material is in powder form, then there are n million number of atoms which are oriented to particular plane, and all these atoms are oriented in different directions, that is they are randomly oriented, and there are the set of parallel planes. In mirror indices we have seen that in crystal there are atomic planes which are oriented in particular direction. The planes which are oriented in a particular direction will have constant value of d, and if they are oriented in different direction they will have different value of HKL, and also they will have different value of D, and hence same phenomena is used here, because in case of powder crystalline material there are millions of atoms are present which are randomly oriented, therefore there are n number of parallel planes or the set of parallel planes which are going to contribute for the diffraction of the X-rays, and uh, giving the positive or the intense concentric rings on the photographic film. I have told you that in the interior of Debye Scherrer camera we are using a photographic film in order to record the interaction of the X-rays with the material, and hence it is observed that from a set of parallel planes not only the first order reflections are possible, but there are higher orders of reflections are also possible from a same plane. It means that for a same plane theta value will be same, d value will be same, but n value will differ, and according to that there will be such number of such cones which are going to form. So for a set of n value fixed, lambda value fixed, theta is fixed, then d value fixed for a set of parallel planes. Now here suppose n1. Now one can have n2, lambda, theta and d, like that. So we will have the higher orders of the X-ray diffractions also, and because of that there is the formation of cone, and the axis of this cone is aligning to the direction of X-ray beam, and the semi-vertical angle of this cone is found to be double the glancing angle. So for a set of parallel planes glancing angle is theta, then the cone which is formed due to the reflection of X-rays from that particular set of parallel planes, it will be twice of theta, and this twice of theta, that is this total value is 4 theta, and the semi-vertical angle is having value 2 theta. So here again I have shown the same here. Here this is 2 theta value, and hence there is the formation of cone, and this cone is forming such type of arcs when it comes in contact with the photographic film. So on photographic film we are going to see arcs, because the film width or the film is having narrow structure, and because of that we are not having such type of circles, but instead of that we are having only curvatures as shown in figure, and hence after developing the photographic film we are going to get such type of strip, and we have to develop it, and that is nothing but the photograph after X-ray diffraction. And now one can analyze this strip and one can find out the value of D, that is D is nothing but interplanar distance. Interplanar distance. So by using this trick one can get value of interplanar distance. So what we have seen up till now, so we have seen that there is one more method of X-ray diffraction and that is called as Debye Scherrer method. It is particular or powder method. It is particularly used to study the materials which are in polycrystalline form or not in single crystalline form, because in nature there are not such type of many single crystalline materials, or if we want to have such type of materials then their method of production is costlier. And in case of love method and rotating crystal method, there is compulsion that the material under investigation should have single crystalline form. So in order to study the various materials which are available in world, there is necessity to have a simple method which will be used for the polycrystalline materials, and that method was invented by Debye Scherrer, and hence it is named as Debye Scherrer method or powder method. In this method, a monochromatic beam or the X-ray source will produce the X-ray beam. That X-ray beam is allowed to pass through filter in order to make it monochromatic. That is, it will consist of single wavelength. Then, in order to make it fine, it is allowed to pass through two slits S1 and S2, which are made up of lead, because lead will absorb the excess of X-rays in the beam and it will make the beam fine. And such type of fine beam is allowed to fall or the incident or bombard on a crystal which is located or which is attached to or which is stuck to the crystal, means polycrystalline material. Our material should be crushed or grounded and then it is stuck to the hair because it is non-diffracting with the help of glue, and it is suspended at the center of Debye Scherrer camera. In the interior of the Debye Scherrer camera, we are attaching a photographic film to record the interaction of X-rays with the powder. So, after having the interaction of X-ray with the powder, we know that in case of powder there are millions of atoms, and these atoms are randomly, they are having, as they are having crystalline nature, therefore there is regular periodic arrangement of atoms. If we observe the various planes, same as in Miller planes, then there is the definite orientation of such planes for a set of theta, or for the angle of incidence theta, there are number of planes which are parallel to each other, and there are n number of such parallel planes which are present in the powder material, and hence probability of having Bragg's condition fulfilled is more in case of powder method. And hence it is seen that when there is interaction of the X-rays with the powder, then there is the formation of a cone. This cone is formed due to set of a single set of parallel plane with having order n, and for the value of n or n1, n2 higher order, such types of uh, cones are formed, and hence when these cones impinge on the photographic film, then they are going to produce a circular ring. But as the size of the film is not cylindrical completely, so it is narrow. So instead of having a circular ring like this, we are getting only the such type of arcs. And we know that one can easily measure the diameter of this each arc, and 2 theta is nothing but the semi-vertical angle which is made by the cone, which is formed by the reflection of X-rays for a particular set of parallel planes, and the axis of this cone is along the direction of X-ray used. And like that we have now obtained the photographic film in this way, and one can develop it, and by using the formula L1 upon pi d is equal to 90 upon 360 degree. One can find out the value of 4 theta. This is 2 theta, 2 theta. It gives us 4 theta here. And L1. L1 is nothing but, because we are considering this whole, for this half part there is 2 theta. For this half part there is semi-vertical angle is 2 theta. Hence for this complete L1 the angle is 4 theta 1. So L1 upon pi d. L1 upon pi d is equal to 4 theta 1 upon 360. So what is d? D is nothing but the diameter of the camera, or it is diameter of the strip, photographic strip. So we know that L1 upon pi d is equal to theta 1 upon 90 degree. So theta 1 is equal to L1 upon pi d, this is d, into 90 degree. So we have obtained the value of theta 1 for maximum reflection, and hence by substituting the value of theta 1 for particular set of parallel planes, one can obtain 2d sin theta is equal to n lambda. One can obtain the value of d, that is d is equal to n lambda upon 2 sin theta. And as we have taken theta 1, one can write here theta 1. So one can find out interplanar distance by using this method. So after this I will explain you again. Here we have obtained such type of photographic film or photograph, and these are the circular rings, but due to the narrow structure of the photographic film, we are getting such type of curved surfaces. We have to measure the length of each ring. Then it comes out as L1, L2 or L3. Then you have to measure the diameter. This is the radius. You have to measure the diameter of the photographic film. It is d. So L1 upon pi d is equal to 4 theta 1 upon 360 degree. Will help to calculate the value of theta 1. So theta 1 value comes out as L1 upon pi d into 90 degree. And we know that 90 is constant, pi is constant, diameter of film is constant, only variable is L1. So by using Bragg's law, 2d sin theta is equal to 1 lambda n lambda, we have to substitute the calculated value of theta 1 in this formula and calculate the value of d, as d is equal to n lambda upon 2 sin theta. Now we know that d value may vary, but characteristic value is the a value, and we know that a is equal to d is equal to a upon square root of h square plus k square plus l square. So after that one can find out the value of a, which is the characteristic of the material, and hence the powder diffraction method is widely used to study whether the material is in single crystalline form or it is in polycrystalline form. Then single crystalline, this method, Debye Scherrer method, is used to study, I will rub this, not single crystalline form or polycrystalline form. It is basically meant to study only polycrystalline materials. The applications of powder method are, with this method one can study whether the material is crystalline or amorphous, because only in case of crystalline material such type of concentric rings will be observed. In case of amorphous material, such type of crystalline uh, such type of pattern or the photograph will not be observed, because in case of amorphous materials, Bragg's law will not be fulfilled. So one can determine the type of material whether it is crystalline or amorphous. Then with this method one can find out the size of unit cell. Size of unit cell can also be determined with the help of this photograph. Then with this method one can determine whether the material is having crystalline nature or amorphous nature. Then one can determine the size of unit cell. Also one can determine the presence of any element or impurity, because the photograph will show the arcs related to value related to that impurity atom. Then it is used to study the presence of, suppose we give the heat treatment or we produce any mechanical strain in the sample, then that can also be analyzed with the help of this photograph, because the photograph before treatment and the photograph after treatment will have different pattern, and therefore the effect of such type of treatments which are given to material can also be studied with the help of Debye Scherrer method or powder method. Mechanical strain produced in material can be studied, and for this you will require a photograph before treatment and photograph after treatment. Then and then only you are able to compare these things, and also in order to identify the impurity or the presence of any element one can use this powder method. So students, in our today's lecture we have covered our last method which is in our syllabus, that is powder method. This method is very much useful from the research point of view, as it covers the study of various polycrystalline materials, and by using this method one can determine whether the uh, material under observation is having crystalline or amorphous form. Then one can determine the size of unit cell and the type of crystal, and type of crystal, type of crystal. It means that it is having simple cubic structure, body centered cubic structure, face centered cubic structure, and like that one can study with the help of this powder method. Also the presence of impurity elements can also be studied. Effect of heat treatment or mechanical strains can also be studied with this method. Thank you.